Good morning, everybody. I am Anusha, faculty of Computer Science, working as assistant professor in Institute of Aeronautical Engineering. In my videos, I was discussing about programming with objects, which is based on Java. In the previous videos, we have discussed about how to create multiple threads, how we can assign priorities to the threads, and how we are interrupting the threads. Now, in today's video, we will be discussing about synchronizing the threads and inter-process communication. So, why do we need synchronization? As we have seen, Java allows multi-threading. That means you can have more than one thread executing at the same time. Now, let's think of a scenario wherein there is one file and we have three threads working on the same file. So, let's say the thread 1 is writing into a variable named, say, A as 10. And later, this value will be used by the thread for some other work. But we have the thread 2, which is again rewriting this variable A into some value 20, and this T2 will be accessing the value 20 for its own need. Now, so what happens here? The value which was written by T1 is overridden, and that value is lost. So T1 will not be able to access the value 10 of A. So this may create two unstabilized states of the thread. So in order to prevent such inconsistency, they go for synchronization. So this allows it prevents one thread from writing the data while another thread is accessing that data. So for this purpose, we go for inter-process synchronization. So we go for the synchronization. So the synchronization is achieved by the use of monitor. So whenever whenever a thread is making use of any resource for its reading or writing purpose, this that thread will set a lock onto that on that resource which it is being used. So that can be achieved by the use of monitor. So when a thread enters a monitor, like when a thread is using any file, and it will apply a lock on it and it enters a monitor. So once that thread has locked any resource, any other thread trying to access that resource will be made to wait for some time until this thread, currently executing thread T1, finishes its work. So to achieve that, we go for synchronization, so that there is no interleaving of data, or there is no inconsistency in the data. Now, in Java, we ensure the synchronization by two ways. One is by the use of synchronized methods, and the other is by the use of synchronized statements. So when we apply these synchronized methods, or when we make use of the synchronized statements, it will prevent the interleaving of objects and producing a inconsistency state. So we make use of synchronization to prevent thread interference and to prevent consistency problem, to stop creating inconsistent states of the system. So for that reasons, we make use of the synchronization. Now let's look into an example of using synchronized methods. So if we have a method to be synchronized, we apply the keyword synchronized on it. So this is the syntax of applying synchronized keyword on the method. So we are making the send method to synchronize, so that whatever data is being sent by it will be in a synchronized manner. In our case, let's look into the example how it is working. Here we are having three threads. We are creating three threads, S1, S2 and S3. So with values in it as welcome, IARE and to synchronization of threads. So these three threads are started. So which thread will start at the first will be determined by the operating system by making use of various um, there are various methods to various methods by which the operating system decides which thread has to be executed first. It may be like first come first serve, or one with the highest priority. Depending on the priority, based on all those things, it will decide which thread has to start first. So let's say we are in fractions of difference of fractions of seconds, all these threads are starting. So let's say first we are starting thread S1. So when S1 is starting, let's see what we have defined inside the thread threaded send. So here we have a thread named as thread send, which is created by extending the thread class. Inside that we have a string named as message, and we are making use of an sender object. So again, in this whatever message is being sent to it is stored into its message, and we are initializing the sender object. And now once the thread start executing, the message is being passed to the send method of sent method. So inside this sender class, what we are doing, we are sending a square bracket, then some message. So let's say first message was welcome, so it will send welcome, then it will close this bracket. So this is, then after that we have to say again, it will the second thread will send square bracket. Let's say the second message was Java, so and then the square method. So and third one was let's say, so whatever message we are creating on the thread, that message will be displayed in between these square brackets. So that is how we have to that is the work of this sender class send method. So whatever message we sent will be displayed between the square bracket. So let's say how that is working. So now let's say we have created the thread, we are creating 3 threads, S1, S2 and S3, and we are starting them. So when they start, the run method will create, so at this point it will create 3 objects, S1 with welcome, S2 with IARE in it, message IARE, and S3 with to synchronization of thread. So these are the messages which is present inside the which is stored inside the thread, and we are starting them. So once they are started, it will go into this thread and it will send the message. So whatever message we have passed, the message, see, we are passing this message welcome and send object. So here that message will be taken into M and it will be stored into the message variable of the that thread for each case. So for each case, that message passed will be stored into that into the message variable, and we have the sender object obj. So once it start executing, this message will be passed on to this sender. So it is calling sender.set. So it is, the sender is the object reference of sender class. So to that object, to that we are passing this message. So once that message is called, it will first display the square bracket and the message. So first our message was what? Our message was welcome. So we get a welcome. Then it will sleep for some time. So it will sleep it will sleep for some time. Now, since we are having this synchronized keyword, what will happen? This process will be working in a synchronized manner. If we don't keep this keyword synchronized, if we don't keep it, then we get the output in an interleaved manner. Let's say, like, it will be, so it will display this thing and welcome message. Then it is going to sleep. So when it sleeps, the second thread will get executed. So the second thread will display its square bracket and its message. So let's say IARE. And then by this time, after this message is printed by the second thread, then it will go to sleep. So when that goes to sleep, if the first thread has waken up, then it will execute, or else the third thread which is alive will be executing. So you get the message like this. So then the three square brackets will be displayed. So you're getting the output in an interleaved manner in case we don't use this keyword synchronized. So to prevent this interleaving, we are making use of the synchronized. So what happens? It will print the message, then it will display the square bracket. Then only will the second thread and the third thread will execute the work. Now, so that is how synchronization is achieved by making use of synchronized keyword. And this is the since we are applying the synchronized keyword over the method, this is called as synchronized methods. Now, another way of achieving synchronization is by making use of synchronized statements. So in that case, we won't have, let's say we are having 50 lines of code, of which we don't have to synchronize all 50 lines of code. We want to synchronize only, let's say, 5 or 6 lines of that code. So in such cases, we will make use of we will apply the synchronized keyword on that set of lines only. So it is also called as synchronized block or synchronized statements. So the same example is being implemented using the synchronized statements. Let's look into how that is working. So in this case, in the previous case, we had applied the synchronized keyword over sent, but in this case we are applying, because whatever value was being sent to it, that was creating this inconsistency. So we just applied the synchronized keyword over the set of statements on which we want to apply the synchronization. So here it was the send method which was causing the interleaving of a statement. So we are applying the synchronized keyword only over to the set of statements sender. So, and we have to specify the object on which we are going to apply synchronization. So the object on which we are applying synchronization is the sender, and the set of blocks, set of statements which we have to synchronize is applied by the block. So these set of statements indicate that the synchronized statement is applied over the set of statements. Let's just look into the execution of the program. See, when this is the program which I have just now explained. So here I am executing the program. So you can see how the output is coming. It displayed the square bracket, the message, then it's the second square bracket. After that, the second thread and the third thread. So here we had applied a synchronized keyword on the method send. Now let's see what will happen if we remove it. See, here we are getting the output in an interleaved fashion. All the messages are displayed in an interleaved fashion, and the thread so the output is in interleaved manner when we don't keep the keyword synchronized. So I'm giving the keyword again. So what we will get? Now we get the output in the synchronized way. After the display of first message, it is displaying the second and the third. Now this order of execution will be determined by the operating system. The order in which the thread will be executed will be determined by the operating system scheduling algorithms like FCFS or other algorithms. So based on that only, the threads will be started execution. So this is about how we achieve synchronization in Java. Next, let's look into the inter-thread communication. So we have seen there are multiple threads working in a system. So what can happen if we have one system in that there are lot of threads working? So these threads may communicate among themselves. So uh, there are various methods which is used to communicate among themselves. They can make use of the polling method, or they can make use of methods like as wait. There are various ways by which the threads will execute among each other. Communicate among each other. So like polling is generally implemented by a loop which used to check some condition repeatedly. So once the condition is true, some action will be taken. But this causes the wastage of CPU time. In order to avoid polling, we go for, in Java, there are various methods such as wait, notify all methods to achieve inter-process communication. Now, in our example, let's see how this producer-consumer problem is handled. So, this producer-consumer problem is one of the best IPC example. So, what happens in producer-consumer problem is that we will have we have a resource, say item. So the producer will have to produce this item and store it into its buffer, and the consumer will be taking that item produced by the producer, and it will consume it. So this is this will happen as a loop, like it will execute multiple times. So we'll look into how that inter-thread communication is implemented. So let's look into the various method which is used for inter-thread communication in Java. One of the method is wait, which causes the current thread to wait until it is awakened by being notified or being interrupted. Another form of wait is wait with some time limit. So this will also cause the current thread to wait until it is awakened by being notified or being interrupted, or by until this amount of time is elapsed. Similarly, the wait with can be specified in nanoseconds also. So this also will cause the current thread to wait until it is awakened by notification or by interruption, or until this specified time is elapsed. So these wait methods will throw illegal monitor thread state exception and the interrupted exceptions. Another method which is used is the method notify, which will wake up a single thread that is waiting on this object's monitor. If any threads are waiting on this object, then one of them will be chosen to be awakened. This choice is arbitrary and occurs at the discretion of the implementation. So if there are we have one source and there are multiple threads waiting for it, then notify method will awaken one of them at arbitrary choice. Another method is notify all, which will notify all the threads which is waiting for that. So it will wakes up all the threads that are waiting for this object's monitor. Next, let's look into the producer-consumer problem using threads. So the producer will always generate data, put it into the buffer, and it will go to sleep. So it will sleep until the consumer consumes that data and make the buffer empty. So once the producer produce data and put it into the buffer, it will notify the consumer saying that a data is processed, you can consume it to the consumer. And similarly, the consumer will, once it consumes the data, it will inform or notify the producer saying that the consumption has been done and the buffer is empty. So once the producer sees that the buffer is empty, it will again produce and this work repeats. So if the producer finds that the buffer is still full, it will wait for some time. It will go to sleep, or it will wait until that buffer is being empty. So the producer will not keep on adding data when the buffer is full, and the consumer will not try to remove data when that buffer is empty. So this is the basic producer-consumer problem. So we have our buffer, or our item is represented by the class item, wherein it is having a value a variable called value, which indicates the uh, which indicates the buffer or the data to be stored. And there are two methods, set item and get item. The set item is used by the producer to store value into the buffer, or the store the value, and that means the producer is placing the item into that buffer, and get item is used by the consumer to consume the data from the buffer. And there are two threads for producer and consumer. The producer thread will produce the item and store it into the buffer, whereas the consumer thread will consume the item from the buffer. So let's see how they will work. So initially in our driving class, we have we are creating an item. So we'll create a buffer, and the producer will produce the item and store into it, and the consumer will consume the item and consume the data. So what happens in this is that, let's say, what will producer do? The producer will make use of the the put item method, or the set item method, and it will store the data into the buffer. It will store the data into the value. And then, so before storing the item, it has to see whether the buffer is full or not. So if the buffer is full, it will go to, it will wait. And if the buffer is empty, it will consume the value. So to check whether the buffer is full or not, the producer will check the value set, the value of the value set. If the value set is false, that is, if the value set is false, it will. So if the value set is false, it has to store the item. So it has to store the item. So it will store. It will call the put item method. It will call the put item method, and it will set the value set. It will call the put item method to put value store the value into the buffer, and it will set the value set variable to true, and it will notify the consumer. It will notify the consumer. Now, in case it finds that the value there is some value in the in that variable, or if it finds the value set is true, then it will wait. If the value set was true, then the producer will wait. So we have our producer. So here the producer is producing an item. So once the producer is creating an item, see, it will set the it is creating an item. So the producer is producing the item. Now once the producer starts executing, so when the producer starts executing, it has to set the value of, it has to set the value. So it will call the set item method of the item class. So set item, what is happening inside the set item? It is checking whether the value set is true or false. So if initially the value set was false, so this was false. So if false means this set of statements won't get executed. So it will come here, since value is the I value was a default variable, the initial value will be 0. So that value of 0 will be stored into value. So the item's value will be set to 0. And then the statement will be displayed by this. So producer placing, so put 0 statement will be displayed. It is notifying the consumer, and it will set the value set to true. So when value set is set to true, it indicates that there is some item inside the buffer. So the consumer now will check the value set value. So once the consumer start producing, once the consumer start executing, it will also create this item, and it will come here. It will check whether it will yes. So the consumer will, once the consumer start executing, it will call the get item method. So inside the get item, it is checking the value set. So in the producer had the producer had set the value set to true. The producer had set value set to true. So this will be true. So if true, if not true means it will be false. So if not true means this will be false. So this path won't get executed since there is some value inside the buffer. So it has to consume it. So what will happen? It will display the statement get 0, and it will notify the producer. Then it will set the value set to false. So now when value set is set to false, value set is false, it indicates that the producer has, the consumer has consumed the item, and it has to, consumer has to consume the item, and the buffer will be empty. So the producer has to start producing again. So now the value set is false here. So again, once the consumer consumed and the notify method was invoked, the producer will again execute the set item method. So the producer will again place the item. So again the set item will be set. So producer will be calling the set item. So set item will be called on I++. So now the value will become 1. Initially value was 0. So now the value will become 1. So what will happen? In that case, again the value set was false, so the if block won't be executed. So it will, now the I value is 1, so value will be set to 1. Value will be set to 1. Value is set to 1, and it will display put I. So that means it will display put 1, and then it will notify the consumer, and it will set the value set to true. So once the value set is set to true, the value set is set to true. So the consumer will start executing. So the consumer will call get again it will call get item. So once it calls get item, it will come here. The value set was true. So again, not true means this will be false. So again, this part won't be executed. The if block won't be executed. It will come to the rest of statements. It will place get 1. And then notify the consumer. It will reset the value of value set to false. So value set will be false now. Since it is false, this data will the producer will be invoked. The producer will again start executing the set item on I++. Again here the value will be executed on I++. So the value will be now 2. So value will be 2. And since the value set is false, again the block of the if block won't be executed. It will come down to value. So it is that value was set to 2, and then it will put 2. So what will be getting the output? Initially it was put 0, then we'll get 0, then put 1, get 1, then it will be put 2. By this time it will get put 2. Then once it has placed value into the buffer, it will notify the producer. Sorry, it will notify the consumer by setting the value set to, and set the value set to true. So once value set is set to true, the consumer will call get item method. So get item, inside get item, the again the if block won't be executed, and it will put the statement put 2. Sorry, it will write the statement get 2, and the value set will be set to false, and it will return the value. So we get these set of statements repeated for some time. So this is how inter-thread communication. So here in our case, there are 2 threads, which is the producer and the consumer. So these are the 2 threads which are communicating among themselves. So the producer and they are making use of the notify method of IPC for informing each other, for communicating among each other. These methods are being called. Also, these wait methods are used so that there is proper synchronization among these threads, so that the consumer won't try to access from an empty buffer, and the producer will not try to put the data into non-empty or a full buffer, a buffer which is full. It won't try, the producer won't put items into an already full buffer. So this, for that, synchronization is achieved by wait method, and the notification among themselves while after consuming the items and placing the items is made use by the notify method. So this is how we get the output in after execution. We will get the statements of placing the input, placing the item, and by the, this is placing the item by the producer, and the get statement will be by the consumer. So once the producer places the item, only then the consumer has to consume the item. So these set of statement will be executed synchronously. So that is all for today's video. To prepare these slides, I have made use of the textbook Java Complete Reference 9th edition and the websites or the Java tutorial from Oracle and Java T-Point websites. In today's video, we had discussed about inter-process communication and how we can achieve synchronization of threads. That is all for today. We will meet in the next video. Thank you for watching the video.
Like, share and subscribe. Hit the bell icon for more updates.